When you write a fraction, there are actually words for the top number and the bottom number. And the words are a lot more fancy than the word top number and bottom number. What mathematicians typically use is the word numerator for the top number, and denominator for the bottom number. Denominator for the bottom number. Now what I want to do now that we know that the top number is the numerator of the fraction, the bottom number is the denominator, I want to compare pairs of fractions that have either the same denominator or the same numerator. So let's look at this first pair. I want to compare 4/7 to 3/7. And I have two wholes right over here. They're the same whole, and I've divided them into sevens. I've divided them into 7 equal chunks. And I want to see what's larger, 4/7 or 3/7. So what I can do is I can fill in 4/7. Let me select 4 out of the 7. So that's 1, 2, 3, 4. And the fact that trying to even get to 4/7, I had to have 3/7 first gives you a good clue that 4/7 is probably larger, or it is larger. But now let's color in 3/7 just so we can compare. So 1, 2, 3/7. And so it's pretty clear that on the left-hand side we are shading in more of the whole than on the right-hand side. So 4/7 represents a larger fraction, more of the whole than 3/7. And the way that we can state that comparison mathematically is with the greater than symbol. We can write 4/7 is greater than 3/7. Now the greater than and less than symbols can sometimes be confusing. This is greater than, this is less than. So this is greater than, this is less than. And the way that I remember it is that the greater than symbol, either symbol, the small pointy side is always on the side of the smaller number, and the big open side is always on the side of the larger number. So here, big open side is opening towards the 4/7, small pointy side opening to the 3/7. 4/7 is greater than 3/7. Now what about 3/7 and 3/4? So here I have different denominators, but I have the same numerator. And so I encourage you to pause this video and draw maybe little boxes like this and try to judge for yourself which of these is a larger fraction, represents a larger number. Well, let's color them in. So let's think about 3/7 first, and we actually already drew it here, but I could do it really fast right over here. So that is 3/7. I've colored in 3 of the 7 equal groups. And what would 3/4 be? Well, that's 1/4, 2/4, and 3/4. And so it's pretty clear that 3/4 represents a larger fraction of the whole, that 3/4 is larger, or that 3/7 is smaller. So we could write that 3/7 is less than 3/4. So notice, same exact numerator. When I divided it, because this fraction symbol could also be viewed as division, when I have it as more equal groups, or it's a fraction of more equal groups, so 3 out of 7 versus 3 out of 4, this is a smaller number, which makes sense. Now let's compare these two. We have the same denominator, different numerators. 3/4 versus 2/4. Well, 3/4 we've already looked at. We can just shade in 3 of these. So 3 of these fourths. So that's 3/4 right over there. And then 2/4, where we're going to only have 2 of the fourths. 1, 2. So 2/4 is clearly the smaller number. 3/4 is the greater number. So once again, we could write 3/4 is greater than 2/4. And then finally, and I encourage you to pause the video, try to come up with whether 2/4 or 3/6 is a larger number. Well, let's color it in again. We've already seen 2/4. We just have to color in 2 of our fourths. So let's just color in 2 of our fourths right over there. And then 3/6, we've split our whole into 6 equal sections. 1, 2, 3, 4, 5, 6. We need to color in 3 of them. And as you see, we are coloring in the exact same amount of the whole. These two fractions are equivalent. These are equivalent fractions. 2/4 is equal to 3/6. And as you see here, they're both filling in half of the whole. If we were to just draw the whole and split it only, let me do this in a different color. If we have our whole, and we were to split it only into two sections, we are shading in exactly one out of the two sections. One out of the two sections. So you could say that 2/4 is equal to 3/6, and they both equal 1/2. They all equal, so 1/2 is equal to 2/4 is equal to 3/6. Let's compare the fraction 4/7 to the fraction 5/7. And what I want you to do right now is to pause this video and think about which of these fractions represents a larger quantity. I'm assuming you've had a go at it, and the one thing that might jump out at you is that they both have the same bottom number, which we call the denominator. They both have a denominator of 7. So one way to think about it is this is literally 4/7. This is literally 5/7. So we could rewrite 4/7 as literally 4 times 1/7. And we can rewrite 5/7 as literally 5 times 1/7. It's 5/7. 5/7. So now if I have 4 of something versus 5 of something, which is going to be a larger quantity? Well, clearly 5 of this 1/7 is going to be more. So 4/7 is smaller, 5/7 is larger. And so what we can do is we can write a less than symbol. And the way that I remember less than and greater than is that the point, the small side of the symbol, always is on the same side as the smaller number. So this could be read as 4/7 is less than 5/7, or that 4 times 1/7 is less than 5 times 1/7. Now let's do another scenario, but instead of having the same denominator, let's have the same numerator. So let's say we want to compare 3/4 versus 3 over, let's say, versus 3 over 9. Which of these two fractions is a larger number? And once again, pause the video and try to think about it on your own. Well, as we mentioned, we don't have the same denominator here. We have the same top number instead. Here is the same bottom number, same denominator. Here we're going to have the same numerator. We have the 3 right over there. And we could view 3/4 as literally 3 times 1/4. And we could view 3/9 as literally 3 times 1/9. 3 times 1/9. So we have 3/4 and we have 3/9. So we really just have to think about what's larger, a fourth or a ninth. Well, think about if you start with a whole. Think about starting with a whole like this. Think about starting with a whole. Let's draw and let me make a hole right over here. A hole right over here. So the same sized hole. A fourth is literally taking the whole and dividing it into 4 pieces, while a ninth is taking the whole and dividing it into 9. 9 equal sections, I could say. So let's divide this into 4 equal sections. So my best attempt to hand draw equal sections. So that's 2 equal sections, and then that looks pretty close to 4 equal sections. So that right over there is 1/4. And let me draw ninths here. So let me first split this into 3 equal sections. So those would be third, and then split each of those into 3 equal sections. So this is my best attempt at that, at hand drawing 9 equal sections, splitting the whole into 9 equal sections. So when you see here, and you might have already realized this, if you divide something into 4 equal sections, each section is going to be bigger than if you divide it into 9 equal sections. A ninth is smaller than a fourth. A ninth is smaller than 1/4, so 3/9 is going to be smaller than 3/4. So once again, when you want to do less than or greater than, you want to put the point, the small side of the symbol, on the same side as the smaller number. So it would look like this. And this is the greater than symbol because you're literally, what you have on the left is the larger number. 3/4 is greater than 3/9. And if you actually wanted to represent not just 1/4 and 1/9, we could actually color it in. 3 times 1/4, well, that's 1, 2, 3. While 3 times 1/9, or 3/9, is 1, 2, 3. And when you look at it that way, it's pretty clear. But the important thing to realize is that when the denominator is larger, you're dividing the whole into more pieces, so each piece will be smaller. So making the denominator larger makes the fraction smaller. Making the numerator larger makes the fraction larger.
Determine whether 30/45ths and 54/81sts are equivalent fractions. Well, the easiest way I can think of doing this is to put both of these fractions into lowest possible terms, and then if they're the same fraction, then they're equivalent. So 30 over 45. 30 over 45. What's the largest factor of both 30 and 45? The one let's see, 15 will go into 30. It'll also go into 45. So this is the same thing. 30 is 2 times 15. And 45 is 3 times 15. So we can divide both the numerator and the denominator by 15. So if we divide both the numerator and the denominator by 15, what happens? Well, this 15 divided by 15, they cancel out. This 15 divided by 15 cancel out. And we'll just be left with 2/3. So 30/45ths is the same thing as 2/3. It's equivalent to 2/3. 2/3 is in lowest possible terms, or simplified form, however you want to think about it. Now let's think about 54. Let's try to do 54 over 81. 54 over 81. Now let's see. Nothing really jumps out at me. Let's see. 9 is divisible into both of these. We could write 54 as being 6 times 9. And 81 is the same thing as 9 times 9. You can divide the numerator and the denominator by 9. So we could divide both of them by 9. 9 divided by 9 is 1. 9 divided by 9 is 1. So we get this as being equal to 6 over 9. And let's see. 6 is the same thing as 2 times 3. 9 is the same thing as 3 times 3. We could just cancel these 3's out, or you could imagine this is the same thing as dividing both the numerator and the denominator by 3, or multiplying both the numerator and the denominator by 1/3. These are all equivalent. I could write divide by 3 or multiply by 1/3. Actually, let me write divide by 3. Let me write divide by 3 for now. I don't want to assume you know how to multiply fractions, because we're going to learn that in the future. So we're going to divide by 3. 3 divided by 3 is just 1. 3 divided by 3 is 1. And you're left with 2/3. So both of these fractions, when you simplify them, when you put them in simplified form, both end up being 2/3. So they are equivalent fractions. Use less than, greater than, or equal to compare the two fractions 21/28, or 21 over 28, and 6/9, or 6 over 9. So there's a bunch of ways to do this. The easiest way is, if they had the same denominator, you could just compare the numerators. Unlucky for us, we do not have the same denominator. So what we could do is we can find a common denominator for both of them and convert both of these fractions to have the same denominator, and then compare the numerators. Or, even more simply, we could simplify them first and then try to do it. So let me do that last one, because I have a feeling that'll be the fastest way to do it. So 21 over 28, you can see that they are both divisible by 7. So let's divide both the numerator and the denominator by 7. So we could divide 21 by 7. And we can divide, so let me make the numerator, and we can divide the denominator by 7. We're doing the same thing to the numerator and the denominator, so we're not going to change the value of the fraction. So 21 divided by 7 is 3, and 28 divided by 7 is 4. So 21/28 is the exact same fraction as 3/4. 3/4 is a simplified version of it. Let's do the same thing for 6/9. 6 and 9 are both divisible by 3. So let's divide them both by 3 so we can simplify this fraction. So let's divide both of them by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. So 21 over 28 is 3/4. They're the exact same fraction, just written in a different way. This is the more simplified version. And 6/9 is the exact same fraction as 2/3. So we really can compare 3/4 and 2/3. So this is really comparing 3/4 and 2/3. And the real benefit of doing this is now this is much easier to find a common denominator for than 28 and 9. Then we would have to multiply big numbers. Here we can do fairly small numbers. The common denominator of 3/4 and 2/3 is going to be the least common multiple of 4 and 3. And 4 and 3 don't share any prime factors with each other. So their least common multiple is really just going to be the product of the two. So we can write 3/4 as something over 12, and we can write 2/3 as something over 12. And I got the 12 by multiplying 3 times 4. They have no common factors. Another way you could think about it is 4, if you do a prime factorization, is 2 times 2. And 3, it's already a prime number, so you can't prime factorize it anymore. So what you want to do is think of a number that has all of the prime factors of 4 and 3. So it needs 1, 2, another 2, and a 3. Well, 2 times 2 times 3 is 12. Either way you think about it, that's how you would get the least common multiple, or the common denominator for 4 and 3. Well, to get from 4 to 12, you've got to multiply by 3. So we're multiplying the denominator by 3 to get to 12. So we also have to multiply the numerator by 3. So 3 times 3 is 9. Over here, to get from 3 to 12, we have to multiply the denominator by 4. So we also have to multiply the numerator by 4. So we get 8. And so now when we compare the fractions, it's pretty straightforward. 21 over 28 is the exact same thing as 9/12, and 6/9 is the exact same thing. 6/9 is the exact same thing as 8/12. So which of these is a greater quantity? Well, clearly we have the same denominator right now. We have 9/12 is clearly greater than 8/12. So 9/12 is clearly greater than 8/12. Or if you go back and you realize that 9/12 is the exact same thing as 21 over 28, we could say 21 over 28 is definitely greater than, and 8/12 is the same thing as 6/9 is definitely greater than 6/9. And we are done. Another way we could have done it, we didn't necessarily have to simplify that. And let me show you that just for fun. So if we were doing it with, if we didn't think to simplify our two numbers first, I'm trying to find a color I haven't used yet. So 21 over 28 and 6 over 9. So we could just find a least common multiple in the traditional way without simplifying first. So what's the prime factorization of 28? It's 2 times 14, and 14 is 2 times 7. That's its prime factorization. Prime factorization of 9 is 3 times 3. So the least common multiple of 28 and 9 have to contain a 2, a 2, a 7, a 3, and a 3. Or essentially, it's going to be 28 times 9. So let's over here multiply 28 times 9. 28 times 9. There's a couple of ways you could do it. You could multiply it in your head 28 times 10, which would be 280, and then subtract 28 from that, which would be like, what, 252? Or we could just multiply it out if that confuses you. So let's just do the second way. 9 times 8 is 72. 9 times 2 is 18. 18 plus 7 is 25. So we get 252. So I'm saying the common denominator here is going to be 252. 252 and 252. Least common multiple of 28 and 9. Well, to go from 28 to 252, we had to multiply it by 9. We had to multiply 28 times 9. So we're multiplied 28 times 9. So we also have to multiply the numerator times 9. So what is 21 times 9? That's easier to do in your head. 20 times 9 is 180, and then 1 times 9 is 9. So this is going to be 189. To go from 9 to 252, we had to multiply by 28. So we also have to multiply the numerator by 28 if we don't want to change the value of the fraction. So 6 times 28, 6 times 20 is 120. 6 times 8 is 48, so we get 168. Let me write that out just to make sure I didn't make a mistake. So 28 times 6 is 8 times 6. 8 times 6 is 48. 48. 2 times 6 is 12, plus 4 is 16. So right, 168. So now we have a common denominator here. And so we can really just compare the numerators. And 189 is clearly greater than 168. So 189 over 252 is clearly greater than 168 over 252. Or that's the same thing as saying 21 over 28, because that's what this is over here. The left-hand side is 21 over 28 is clearly greater than the right-hand side, which is really 6/9.
What I want to do in this video is order these fractions from least to greatest. And the easiest way, and the way that I think we can be sure we'll get the right answer here, is to find a common denominator. Because if we don't find a common denominator, these fractions are really hard to compare. 4/9 versus 3/4 versus 4/5, 11/12, 13/15. You can try to estimate them, but what you can get you'll be able to directly compare them if they all had the same denominator. So the trick here, or at least the first trick here, is to try to find that common denominator. And there's many ways to do it. You could just pick one of these numbers and keep taking its multiples and find that multiple that is divisible by all the rest. Another way to do it is look at the prime factorization of each of these numbers, and then the least common multiple of them will have to have at least all of those prime numbers in it. It has to be composed of all of these numbers. So let's do it that second way, and then let's verify that it definitely is divisible. So 9 is the same thing as 3 times 3. So our least common multiple is going to have at least 1 3 times 3 in it. And then 4 is the same thing as 2 times 2. So we're going to also have to have a 2 times 2 in our prime factorization of our least common multiple. 5 is a prime number, so we're going to need to have a 5 in there. And then 12, I'm going to do that in yellow. 12 is the same thing as 2 times 6, which is the same thing as 2 times 3. And so in our least common multiple, we have to have 2 2's, but we already have 2 2's right over here from our 4, and we already have 1 3. We already have 1 3 right over here. Another way to think about it is something that is divisible by both 9 and 4 is going to be divisible by 12, because you're going to have the 2 2's and you're going to have that 1 3 right over there. And then finally, we need to be divisible by 15's prime factors. So let's look at 15's prime factors. 15 is the same thing as 3 times 5. So once again, this number right over here already has a 3 in it, and it already has a 5 in it. So we're cool for 15, for 12, and obviously for the rest of them. So this is our least common multiple, and we can just take this product. And so this is going to be equal to 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. 36 times 5. 36 times 5. You could do that in your head if you're like, but I'll do it on the side just in case. 36 times 5, just so that we don't mess up. 6 times 5 is 30. 3 times 5 is 15, plus 3 is 180. So our least common multiple is 180. So we want to rewrite all of these fractions with 180 in the denominator. So this first fraction, 4/9, is what over 180? To go from 9 to 180, we had to multiply the denominator by 20. So let me do it this way. So if we do 4 over 9, to get the denominator of 9 to be 180, you have to multiply it by 20. And since we don't want to change the value of the fraction, we should also multiply the 4 by 20. So we're just really multiplying by 20 over 20. And so 4/9 is going to be the same thing as 80 over 180. Now let's do the same thing for 3/4. 3 over 4. Well, what do we have to multiply the denominator by to get us to 180? So it looks like 45. You could divide 4 into 180 to figure that out. But if you take 4 times 45, 4 times 40 is 160. 4 times 5 is 20. You add them up, you get 180. So if you multiply the denominator by 45, you also have to multiply the numerator by 45. 3 times 45 is 120 plus 15, so it's 135. 135, and the denominator here is 180. Now let's do 4/5. 4 over 5. To get the denominator to be 180, what do you have to multiply 5 by? So 5 let's see, if you multiply 5 by 30, you'll get to 150, but then you have another 30. So you have to multiply it. Oh, actually, we know it right over here. You have to multiply it by 36. Multiply by 36. Well, then you have to multiply the numerator by 36 as well. And so our denominator is going to be 180. Our numerator, 4 times 30 is 120. 4 times 6 is 24, so it's 144 over 180. And then we have only 2 more to do. So we have our 11/12. 11 over 12 is, so to get the denominator to be 180, we have to multiply 12 by, so 12 times 10 is 120, and then you have 60 left, so you have to multiply it by 15. 15 in the denominator and 15 in the numerator. And so this gives us, the denominator gives us 180. And 11 times 15. So 10 times 15 is 150. And then you have one more 15. So it's going to be 165. 165. And then finally, we have 13/15. We have 13/15. To get to our denominator to be 180, you have to multiply it by 12. We already figured out that 12 times 15 is 180. So you have to multiply it by 12. That'll give us 180 in the denominator. And so you have to also multiply the numerator by 12 so that we don't change the value of the fraction. We know 12 times 12 is 144. You can put one more 12 in there. You get 156. Did I do that right? 12 plus 144 is going to be 156. So we've rewritten each of these fractions with that new common denominator of 180. And now it's very easy to compare them. You really just have to look at the numerators. So the smallest of the numerators is this 80 right over here. So 4/9 is the smallest. 4/9 is the least of these numbers. So let me just write it over here. So this is our ordering. We have 4/9 comes first, which is the same thing as 80 over 180. Let me write it both ways. 80 over 180. Then the next smallest number looks like it's this 135 right over here. So then our next one is going to be the 135. I want to do it in that same color. The next one is going to be that 135 over 180, which is the same thing as 3/4, which is the same thing as 3/4. And then the next one is going to be, let's see, we have the 144 over 180. So this is going to be the 144 over 180, which is the same thing as 4/5. And then finally, or we have 2 more. The next is this 156 over 180. So then we have our 156 over 180, which is the same thing as 13/15. 13 over 15. And then we have one left over, the 165 over 180, which is the same thing. So I want to do that in yellow. We have our 165 over 180, which is the same thing as 11/12. Which is the same thing as 11/12. And we're done. We have finished our ordering. So this is, if you're doing the Khan Academy module on this, this is what you would input into that little box there.
Order the fractions from least to greatest. So we have 3 fractions, and we want to decide which one is the smallest, which one's in the middle, and which is the greatest. So one thing we could do is look at the fractions, think about what they mean, and then estimate. 7/10, let's say maybe that could represent 7 of your 10 friends are wearing blue jeans. Well, that's most. Most of your friends are wearing blue jeans. And then for 1/3, we could say 1 of your 3 teachers wears glasses. Well, that's not most. If only 1 of the 3 wears glasses, that's not most of the group. So here's a fraction that represents most of the group. Here's one that doesn't. So the most is probably greater. These two we could compare by estimating and see that this one, 7/10, is probably greater than 1/3. But then we get over here to 5/6, and 5 out of 6, well, again, that's most of the group. But is this most of the group greater than the 7/10 most of the group? That gets a lot trickier. So what we can do is we can try to change these fractions to make them easier to compare. So we don't have to compare tenths to thirds to sixths, because those are all different sizes, different size groups, different size pieces. That's tricky to compare. So we want to change these to be the same size. So we need some number, a multiple of 10, 3, and 6, something we can multiply 10, 3, and 6 by to get a new denominator that will work for all of the fractions. One way I like to figure this out is I look at the biggest denominator, which is 10, and I think of its multiples. The first multiple is 10, because 10 times 1 is 10. Can we change thirds and sixths to have 10 as a denominator? Is there any whole number you can multiply 3 times to get 10? There's not, so we need to keep going. 10 doesn't work. The next multiple of 10 is 10 times 2, which is 20. Again, 3 and 6, is there a whole number we can multiply them by to get 20? Again, no, so 20 doesn't work. How about 30? Let's see, 3, we can multiply 3 times 10 to get 30, so 30 works for 3. How about 6? 6 times 5 equals 30, so yes, 30 can work to be our common denominator. 30 is a multiple of 10, 3, and 6. So let's start converting our fractions to have denominators of 30. We'll start with 7/10, and we want it to have a denominator of 30. So what do we need to multiply by? 10 times 3 is 30. We always multiply the numerator and denominator by the same number. So 7 times 3 is 21. So 7/10 is equal to 21/30. These are equal. We've just changed the size of the group. We've changed the denominator so that they will be easier to compare, but we've not changed what portion of the group we're representing. 7 out of 10 is the same portion as 21 out of 30. And then let's keep going with 1/3. Again, we want a denominator of 30, so this time we'll multiply 3 times 10 to get 30. Again, numerator also times 10. 1 times 10 is 10. 10 out of 30 is the same as 1/3. If you have 10 of the 30 people, again, we'll use the wear glasses example, or 1/3, that is the same size of the group, the same portion. And finally, 5/6. What do we need to multiply here to get 30? 6 times 5 is 30. So we multiply the numerator times 5, and 5 times 5 is 25. So now, instead of these original fractions that were tricky to compare, we have much easier numbers to compare. We have 21/30, 10/30, and 25/30. So in this case, the pieces are all 30ths. They're all groups of 30. So this is much easier to compare. We can simply look at the numerators to see what portion of those 30 the fraction represents. So the first 7/10 is the same as 21 out of 30, whereas 1/3 is 10 out of 30. Well, clearly 21 out of 30 is a larger portion of the group than 10 out of 30. So we were right when we estimated up here that 7/10 is larger than 1/3. But then the trickier one over here, now we can see much more clearly 25 out of 30 is the greatest portion of the group. 25 is more than the 10 or the 21. So we can list these now from least to greatest. The smallest is 10/30, which again, remember, is equal to 1/3. So we can put 1/3 is least, and we can cross that off. Next, it's either 21 out of 30 or 25. 21 is less, and that represented 7/10. So we can say 7/10, because 21/30 equals 7/10. And finally, that leaves us with 25/30, which is equivalent to 5/6. So from least to greatest, our fractions are 1/3, 7/10, and then 5/6.